to appear on your basic science class for today. I am going to take force as a topic. It's a third-term work for your JSS 1 class. And we're going to talk about force. We are going to look at 3 objectives in our class for today. The meaning of force, difference between contact force and non-contact force. We're going to differentiate between magnetic and gravitational force. Let us take the first objective, which is force. What is force? Force is a push or a pull upon an object, resulting from the object's interaction with another object. Whenever there is an interaction between 2 objects, there is a force upon each of the objects. Let me use this rubber band to give you an example. I am an object standing. This rubber band is another object. I, as an object, can apply a force on this band and I'll push. I have pushed. You see the elastic nature of it? Because I apply force, it has expanded. Good. If I have a table or an object before me, if I pull this way, I push out. If I pull in this way, the chair, I push in. The force I put to push it out is force. I've applied force. Pulling it in, I've applied force. Me moving or me running without force of pushing myself, I cannot run. Without force of running, moving, I cannot. So it has to do with the application of force for me to either push myself to go forward or push myself to go backward, like the example of the rubber ring. Force make it to be elastic and pull in back. That is force. 2 objects are interacting. I am interacting with this rubber band. I am interacting with my motion. That's force. So, a force is a push, which I have told you, or a pull upon an object. I have pushed and pulled these objects, resulting from the object interaction with another. Whenever there is an interaction between the 2 objects, there is a force upon each of the objects. There's a force on my part, there's a force on this object. Now let's take, for example, I want you to do an experiment in your home. Get a clay. Put this clay in a bowl. Then get a block, a hard object. Throw it into that soft clay. When you put the clay in the bowl, it's going to be at a level ground with all the clay in the bowl. It will level. But the moment you push in a bottle water in that bowl, you see the shape of that clay in that bowl takes another shape. So force can make an object take another shape. The shape of this rubber ring is just this side. But then I pull it, you see, the shape changes. It changes. So force can change the shape of an object. You can put force on an object. That is what force is. Now the next objective is contact force and non-contact force. Let's see what is contact force and what is non-contact. Now let's take the first objective, a contact force. A contact force. What is a contact force? It's a force applied to a body by another body that is in contact with it. It involves pushing or pulling. A body. This is me. This is this rubber ring. I can push out and I can push in. I can push out and I can push in. Because I am in direct contact with this rubber band, I can push in. I am in direct contact with this fan. I can raise it up, I can take it away. I can bring it to myself, I can drag it out. This. I am in close contact with this marker. I can drop it, I can pick it. So, that's contact because we are two objects. I am an object, this is an object. I can pull it in, I can pull it out. I can push the fan forward, I can push it backward. You see it? I can push the shell back forward, I can push it backward. I am in close contact. But then, what about the non-contact force? Let's find out about the non-contact force. We have the non-contact force. Remember the contact force, the two objects are in close proximity. They work together to make the force work, the push and pull. But the non-contact force, this is a force which acts on an object without coming physically in contact with it. The most familiar is the force of gravity. This force doesn't require two objects to come into close contact. Me as an object and the rubber ring is as another object don't need to come into close contact for non-contact force to happen. But the gravitational rule is a universal rule. Look at the interaction between the aeroplane and the gravity. The pilots know that the aeroplane is up, it must surely come down. You don't see gravity. The aeroplane and the gravity are not in close contact. But the universe know they will happen because it is just a law that is there. A tree that falls from the treetop down, it's not going to land anywhere, it's going to come down because the gravitational force will bring it down. Whether it swings sideways, it surely comes down. That's a non-contact force. There's no relationship between the gravitational force and the leaf. But it happens even if they are not in physical contact. That's a non-contact force. So we have seen the contact and the non-contact. What are the differences between the magnetic and the gravitational force? Let's take our third object. Distinguish between gravitational force and magnetic force. I'm going to discuss 5 points, 5 differences. Gravitational force affects all objects no matter their composition. Provided it's an object that have mass, it will affect it. Because if you throw an object up, if I throw this object up, there is no interaction, but gravity will push it down. You see it? And so, whether it is rubber, metal, whichever composition is going to be affected. But in metal, in magnetic, it affects specific objects. Have you tried to use a magnet to magnet a rubber marker like this? There's no way it's going to magnet. But take it close to a metal, it's going to magnet. So do the experiment in your home. Get a magnet. Try to magnet a rubber object like this. And then try to magnet a metal object. You see, it will be selective. It will magnet the metal object. But for gravity, it will pull it down. Whether rubber, whether anything, it's going to come down. Provided it has mass. Gravity is unique to heavenly bodies alone. Like stars, like the planets, and the rest. But magnetic is naturally occurring to some materials. Magnetic just happens naturally. It's not just unique to heavenly bodies. So some material, natural occurrence, but the other one is unique to heavenly bodies. The third one, if the object have mass, the gravitational force will act. Provided it have mass, the gravitational force will happen. But this one, it can pull objects together or pull away. Remember a rubber band, I have force, it pulls. If I release, it comes in. Changes the shape to whichever shape. Its original shape is not what it has now. It's smaller now. it's big. I can make it in a circular motion, any shape I want to make it into. I can push and pull away. But this one, provided it has mass, it's going to pull them. Gravity is a behavior of space-time itself. Happens in the space, it takes it down. But this is a connection between two objects in close range. Have you taken a magnet? Let me stand here and try to magnet an object there. It's not going to work. But if I go close range, it's going to get it. So it has to be in close range with the object. And then the final one, interact with mass for gravity. This, interacts with more, with things that contain iron, metal. Metallic substance interacts more, while this interacts with mass. So we have seen what force is. We have seen the non-contact force and the contact force. We've equally seen the difference between gravitational force and magnetic force. Watch them over and over, and it will be part of you. This is part 1 of force. For the whole of our term work on your JS1 class, we're going to take force. So I'll see you on our part 2 of our force class. Thank you for dropping by. Subscribe, share. Check this channel. You will see other basic science classes of your JS1 classes and other classes too. Subscribe if you've not subscribed. Give us comment below in the comment box. Do those experiments I've asked you to do. Thank you for dropping by.